Welcome back to the channel. Today we're working on the short block for the supercharged Dakota. I'm here with Tim. We're at Performance Masters and he's going to walk us through the machining and assembly of the short block.
Okay, so we're going to torque the main caps down and verify the dimension on the housing board here. We've got all the blocks all clean, the bolts clean. We're going to lube the thread of the bolts, and then we're going to put a little bit under the head of the bolt so that it'll torque properly. Now, when you put these main caps on these blocks, you'll notice it's going to sit up on one side because it's an interference fit in the block. If you tighten this bolt first and then tighten this one, it's up on this ledge, you can actually break a main cap. So what we'll do is we'll just start one bolt. Now we're ready. Okay, so we're going to pull these things to 85 foot-pounds, and we're going to just snug them up and then come back. And when you torque, you don't hammer the wrench. You want a good torque wrench, so just a smooth, steady pull until it clicks one time. That's it. Okay, we need to know what dimension to look for on our housing boards. We're here at Engine Tech's catalog. We're here. Pull up our Dodge truck. .9 360. Here we are. Okay, we'll click on our bearing part number, and Engine Tech is kind enough to give us all of the dimensions for the shaft and for the housing boards. Also, your recommended oil clearance. Good. Okay, we've got our dial bore gauge set for 3 inches and 3 thousandths, which is the maximum for our bore diameter. And you'll see we are 1 thousandths over the maximum, a little tighter in the back. So then we'll go to the cross and be sure the cap hasn't had. And notice how we get a little tighter there. This being an externally balanced engine, the weight on the balancer causes the front of the crank to kind of move in an elliptic, and that's what you see. It'll tighten up the sides of the cap and it'll increase the vertical. Okay, so we've lightly sanded the mating surface of the cap to get the dimension down to the maximum allowed, and we've installed our 8 series bearings. We set up off the crank, set our dial indicator, and we are 2.5 thousandths clearance, right where we want to be. We could, if we were loose there, the cap, we could decrease this dimension another 0.5 thousandths and still be within spec and still get the clearance we want. And that's where your machine shop comes in, because they're the ones that have to set that. Alright, so you've got your block back from the machine shop. They've set your bearing clearances and everything. Most shops won't do this. If you get it back and these edges are sharp, where they've done any machining, line honing, or whatever, all you want to do is take a file and just break that edge. Doesn't take much. What that'll do is when you slide your bearing in, it won't shave material off the back of the bearing when you push it down in there. I'll do the same thing to the cap. Do a final wash on it. Good to go. Alright, so we've got a brand new set of scat I-beam rods for the 360 Magnum. We've got our rod machine set up to check the dimension on the big end. We're going to check them right out of the box, and then we're going to break them down. We're going to clean them, ARP lube the threads, and retorque them, and then recheck them. As you can see, they do have a little bit out around to them, and they also vary a couple tenths of a thousandths. Once we get them lubed and torqued, we'll take the biggest dimension, put a bearing in, check the clearance, and then we'll figure out what we want our big end to be. Okay, so we've got all our bolts lubed up. We've got lube on the threads and under the head of the bolt. You can start your bolts. You really want to tap the cap gently down onto the dowels, not pull it down with the bolts. And then we're going to run them all up and torque them. What do we torque them to? We measured the underhead length of the bolt. It was 1.4 inch, and according to the SCAT chart, that puts us at 64 foot-pounds on the 7/16 bolt with an 8740 bolt. Okay, so we've got all our rods torqued up. We're going to go back and recheck our measurements. 0 is our maximum that we can be. This one's 2.5 tenths under. This one's about 2/10 under. Too close to call. This one's about 2. And we've got a few, a little more on the tight side, a little out around. We've got 4 of those that are, we'll go back and actually touch them up, get them all the same. So what's this do to our bearing clearance? We're going to check our bearing clearance off the crankshaft, and we are at 2 7/10. Now that is the absolute maximum that you want to run according to the bearing manufacturer for rod bearing clearance. Therefore, just a hot street motor, we would want to be around 2 2/10. The quickest way to get to that is to get a set of 1 under bearings and use half a set of those in the upper part of the rod or the lower part of the rod, and the standards in the other half of the rod. Now that may sound kind of funny, but you talk to your bearing manufacturers, they say you can easily do that. You can shrink it a 1/2 thousandths, you'll be at 2.2, you're good to go. This one, being a supercharged motor, we're going to go ahead and run it at 2.7, even though that's looser than the mains. This is the this will put more oil on the cylinder walls to help with the loading on the pistons. So we're comfortable at 2.7 on this one. That's what we're going to do. Okay, we're getting ready to balance the crankshaft and rotating assembly in this thing. I want to point out a couple things that you may or may not know. You notice we have a reciprocating weight here that says 50%, and then we have a rotating weight 100%. What that is, the big end of the rod bearing spinning with the crankshaft has a direct effect on the weight of the crank as far as counterweights. When you get up to the piston pin, the small end of the rod, the ring pack, that doesn't spin with the crank, but it does exert force on the crank. And we've learned over time that 50% on a V8 engine comes out right on the balance. Now we're going to go in here. I want to show you a couple things. On our pistons, you'll see here we've got one at 550.2 and one at 549. Then you notice we have light pin there, and then here we have a heavy pin. That looks, if you just look at the pins and the pistons, they're off. But when you look at the total weights, they're within 0.6 grams. Now that's straight from Icon. Icon did that. We didn't have to switch the pins around. Sometimes we do, but they got it dead on the money. We don't have to worry about that one at all. Within 1 gram on reciprocating is fine. We get down to our rods. Now here, on our small end, a gram difference is okay there because it's 50% weight, which ends up being 1/2 gram. But on our big end, that is rotating weight. We need to be 1/2 gram there, and we're 418.2 to 420.7. We have one really heavy rod. So we're going to have to go in and do a little work on the big ends of the rods, and the small ends just dial them in a little bit better, and then we'll get an actual bob weight, and we'll get into that when we get that done. Be right back. Okay, we've got our rod weights dialed in. We're pretty happy with them. We're within 1/2 gram on our big end. We're within 1 gram on the small end. Big end, small end. Let me show you how we do that. This fixture is going to weigh the big end of the rod, and then we weigh the total rod weight. And when we put those two numbers in, the computer is going to tell us the small end. When we're done with that, get everything weighed. We're going to come up with a bob weight right here. This is a bob weight. we'll add weights, make these equal both sides. We weigh them in halves, that's why it gives us the number. And this is what we'll attach to the crank in order to spin it. And that will simulate all the components that work on the crank when it's actually in the engine. Alright, so we've got our bob weights attached to our crankshaft, balancer and flywheel on. The flywheel and balancer are both externally balanced. So we've got to have all those components in place. Now we're going to get a spin on it and we'll see what kind of work we got to do. Just for reference, that's only 400 RPM. That's not even idle speed. Alright, so we've got our drill set up for a 7/8 bit, 875 diameter. And it's telling us we need, on the front side, we need one hole here. But then when we go to our second hole, come on, we're going to be right here. And we cannot drill a 7/8 hole that close to that one. That's going to intersect. So we're going to have to get creative. We're going to go back and we're going to roll it over here, go to this counterweight and drill a 1/2 inch hole, which will make this weight shift around, and we'll get to where we can put 2 holes over here and get it done. And odd enough, it does the exact same thing in the back. When we get to that hole, we're right there. So we're going to have to do some offset drilling, a little bit of work to do. We'll see if we can get her close and we'll come back to you. Alright, we finally got it dialed in. If you want to know what 80 grams imbalance looks like, that's it. We had to drill 1 hole here and 2 here to get over to where we could not be drilling an existing hole. And on the front side we did that and got it with 2 holes in the front counterweight. So we're ready for a final spin. Because we're so close to being balanced out, we're going to go ahead and turn it up 600 RPM. That'll give us a little finer resolution. And we are 2.5 grams in the back and 1.2 in the front. That's well within. Ready to go?
Well, that's going to be it for this video. Now that I'm here putting it all together, I realized my shirt was inside out the whole time. Glad I wasn't in front of the camera most of the time. But we're planning on going back to the shop today, mocking everything up so we can check piston and deck clearance, and then we're going to get into quench and seeing things, because we want to make sure the compression ratio is going to be okay, because I'm mainly running pump gas with boost. So if we have to open the chambers up or fly cut pistons, whatever we got to do to make it work. But we'll get into that later. So keep a look forward for that. I'm also going to put a link to Performance Masters Facebook page in the description. They do a lot of hot rod work. Now they're out here in Chattanooga, Tennessee area. But they do a lot of hot rod work. Like you see Tim, the machinist, does a lot of work. Been doing this for 30-something years. He's really good at what he does. But keep looking forward for the next video, and thank you for watching.